4Q1. A farmer has 170 meters of fencing to fence off a rectangular area. They draw it here. It's always good to draw a picture if they don't have one. Length and width. Find the length and width that gives the maximum area. Okay, so let's call the length L and the width W because we're going to make them into variables. We don't know how long they're going to be, but we know that we're going to add all the fence up and it's going to be 170. So the equation to find the area of a rectangle is area equals length times width. And the perimeter, or like the length of the fence all around it, of course, is length plus width plus length plus width. And if you don't remember that it's 2L plus 2W equals the total perimeter, then what you could do is just do this. You just add up everything. So there's like each side is L or W, and you just add up 2L's and 2W's, and you get the total. I have the wrong total here. I'm going to do part A first. So part A says, what's the length and width that gives the maximum area? So that's A equals LW, and L plus W plus L plus W equals 170. Okay, and it doesn't look like there's enough information there to figure it out, but actually, since we have two equations and two unknowns, well, actually, area, we don't know it yet, but we do want to know, we do know that area, we want to make it maximum possible. So that is a piece of information. So what we're going to do is we are going to write A equals, and then we're going to have an equation here with just one variable, for example, L or W. And then we're going to vary L and W until we make A as big as possible. So let me show you how. So how are we going to make this equal to something written with just L or W? It's got both right now. Well, we take this equation here, and we're going to change it so that we solve for L or solve for W, which means we put W or L on the left side, and then we leave everything else on the right side. So let's say we want to solve for W. So we'll say 2W equals, and we're going to subtract 2L from both sides. And so we're going to get 2W equals 170 minus 2L. And then we're going to divide both sides by 2 so that we get W all by itself. W equals 170 divided by 2 minus L. 170 divided by 2 is 85. 85 minus L. So W equals 85 minus L. Okay, now that we have this relationship, we can write A equals L times 85 minus L. Okay, and now we can look at multiplying this out, 85L minus L squared. So we know the area is equal to that. Okay, so now what we can do is we can put this in the calculator and graph it. So we're going to have a graph which has, let's see, instead of A, we're going to have Y, and instead of L, we're going to have X. So 85X minus X squared. We're just changing the names here for the calculator's sake. So we're going to put 85X minus X squared, and then we're going to graph it. Didn't come out too well. Let's see, 85X minus X squared. So probably what's happening is that the parabola is going off the edge of the screen. So the easiest way to fix that is to use the zoom function, and zoom fit is where we should always start. Zoom fit is, I think it's option 9 or 10. Zoom fit, it's 0, option 0. Okay, so now at least we're seeing the parabola. Now, it looks like we're trying to maximize the area, and y is the area. So it's like if we want to see where this thing is the biggest it can be, we need to look to the right here because it's growing to the right and we can't see where it's going. So let's change the maximum value of y with window. So now we'll go to y max. Actually, it's already at 750. Actually, I was trying to write 1500. I wrote 150. Actually, I don't want to change. I messed up again. Sorry. So I'm going to put 1500 here, but I actually want the x max to be something bigger. Right now it's 10. Let's make it like 100. 100. Okay, now let's graph it. Now we can go farther to the right. Oh, there we go. See? Somewhere in there, there's a max value. Okay, so let's try that again. I need to adjust the zoom again. Zoom, zoom fit, and then it'll bring the top down so that I can see it. There it is. Okay, now the question is, where is this point here? Let's figure that out. We use trace, and then, oh, yeah. So it's about x equals 45. That's about the maximum. Looks like x equals 42 or so is also close. To see the exact value, remember that we need to use second calc, maximum. We want to find the maximum point. And the maximum point, so it says, move me a little bit to the left. Okay. Move me a little bit to the right. Do you see the cursor there? It's moving a little bit to the right. So that's definitely to the right of the maximum. Is your guess that? Yes, it is. And then it'll give me its estimate, which is 42.5. Okay, so maximizing y, x is going to be 42.5, and y is going to be 1806.25. Let's see if that answer makes sense. 42.5. If one side of the rectangle, which is length, is 42.5, then what is width going to turn out to be? Well, let's see. We're gonna have 170 meters of fencing. We're gonna subtract off 42.5, which is one length, and we're gonna subtract off 42.5, which is the other length. And what are we left with? We're left with 85. So we're left with 85 to use for the widths, and if we divide it by 2, we get 40. What a surprise, 42.5. So did you know that if you have a certain amount of fence, the way to maximize the area is to make a square out of your rectangle? Okay, so the more rectangular you make it, the less efficient it is. If you have a certain amount of fencing, make a square, and that's the most efficient. Okay, now here we have an interesting variation on the problem. They have a short, fence here, which or not a fence, but a wall, and they're going to use this wall to not have to use so much fencing. And the way the drawing is drawn, it's kind of hard to see, but like let's say you got a wall here. Now you're going to use the fence to try to make a rectangle that has the most areas possible. Okay, and they say it's 15 meters of wall, so that's 15. And then the rest of your rectangle is going to total up to 110 meters of fencing. So let's make the formula again. A equals length times width again, which is going to be, you're trying to maximize that. Now let's try to figure out the next equation, which would be this. Let's say that this is length. They call this length. They call this width. So this is width. And then what would this part be? Okay, because like this part is fence, this is wall. So if we were going to add up how much fence, we would say, okay, the amount of fence is equal to 2L plus W plus, and then this part here is actually W minus 15, right? Because you're subtracting off the piece you have here. Oops, I got that opposite. It's not 15 minus W, it's W minus 15. Okay, so you got 2L plus 2W minus 15, and that totals up to 110, because that's how much fence you got. Now let's, like before, we solved for W and then we put it in the other equation. So we're going to put W on the left and then everything else on the right. Okay. So let's see. Well, let's leave W on the right because it's already there. So we're going to add 15 to both sides. That'll get rid of this 15. Okay. And then we're going to subtract 2L from both sides. So now we have on the left side, we got negative 2L plus 125 equals, and then this one disappears, equals 2W. So what is W equal to? W is equal to 125 divided by 2 minus 2L divided by 2, which is just L. So 125 divided by 2 minus L, which is equal to 62.5 minus L. Okay, and now we're going to go back here, and then for this equation, we're going to put L times 62.5 minus L is equal to, some quantity that we're trying to maximize. So now we just put this equation into the calculator. We go to the y equals screen, and then we type in, let's see, we could just put it in like that. So we're going to substitute the x in for L and the y for A. Okay, and so that's going to be x, which is the L, times 62.5 minus the x. And then close parentheses, and then we graph it. And since we adjusted the window size in the previous problem, it looks fine. We're going to figure out what the max is here. We're going to use the second calc max function. And then we're going to move the cursor close to the max point. You can see where the max point is. It's right about there. So the answer is approximately 33. Let's go a little bit to the left. For sure we're on the right side of it there. So we hit enter. And now we're going to go to a place where we're for sure on the right side. We're pretty close to the max here. We need to go farther to the right. Okay, that's probably good. Enter. And then our guess is that. We hit enter. And it tells us that the maximum is 31.25. Okay, so the maximum is going to be x, which is actually L, is 31.25. Okay, and then what would be W then? W is equal to 62.5 minus L, so 62.5 minus 31.25, which is actually 31.25, so W is 31.25. Okay, so 31.25 here and 62.5 here. Okay, and then this little piece would be 31.25 minus 15.